Well, last time we discussed Ohm's law. From the Ohm's law we know that the resistance R of this conductor is equal to V by I. By dividing voltage by the current that passes through the conductor, we can calculate the resistance of the conductor. The resistance of the conductor can be calculated without using this formula. The resistance can be calculated by just measuring the length of the conductor and its cross-sectional area, and also a property of the conductor, that is the resistivity of the conductor. And today we will discuss about this resistivity. Now let us consider, if the length of the conductor is made twice, then what will happen? If the length of the conductor is made twice, the current flow through the conductor will be reduced by half. That is because the resistance has become twice. The length is made twice means the resistance has become twice. And if the length is made thrice, the resistance of the conductor will become 3 times. That is because the conductor is composed of large numbers of ions, positive ions, and suppose this is a conductor, these are positive ions, and there are free electrons moving just randomly around these ions. And when the electric field is applied by connecting a voltage, then the electrons will start drifting in the opposite direction. Electrons will move in the opposite direction to the flow of the current. So these electrons, they will collide with these ions, and hence the resistance comes up. If the length will be more, then they will face more resistance in their movement, so the resistance increases. Similarly, if the cross section area of the conductor is made twice, then what will happen? If the cross section area is increased, then the electrons will be able to travel more freely, and the resistance or the resistance they will face will be reduced. That's why if the cross section area is increased, then the resistance will decrease. So we can mathematically write that the resistance directly proportional to the length of the conductor. As the length increases, then the resistance of the conductor increases, and resistance is inversely proportional to the cross-sectional area of the conductor. As the cross-sectional area is increased, the resistance of the conductor will decrease. Previously we discussed about the directly proportional thing, and now we will discuss this inversely proportional. What is this inversely proportional? Let us consider, suppose if 50 people can do a job in 40 days, then 25 people can do this job in how many days? Number of people is reduced, so it will be 80 days. And if the number of people will be increased, if 100 people will do the same job, then they can do it in how many days? Number of days will decrease, that will be 20 days. So if the number of people is reduced, so the number of days is increased. If the number of people is increased, then the number of days will be decreased. More people can do it rapidly within few days. So in this case, you can say that the number of people P, that is inversely proportional to the number of days. In case of inversely proportional, it is written as 1 by D. In case of directly proportional, it is written that X is directly proportional to Y, like this, or X is inversely proportional to Z, 1 by Z, like this. So P is directly proportional to, P is inversely proportional to D. This is the inversely proportional. In this case, similarly, the resistance is directly proportional to L, and resistance is inversely proportional to the cross-sectional area of the conductor. Now removing this proportionality constant, we can say that R is equal to a constant. This constant is called rho. R is equal to rho L by A. L is the length of the conductor, and A is the cross sectional area. This is the area. If it is circular, then it will be pi r square. Then r is equal to rho L by A. Rho is called the resistivity material. This is the constant. It is called resistivity of the material. It is a property of the material. For aluminum it is different, for iron it is different, for gold it is different. If the resistivity will be more, then the resistance will be more. R is equal to rho L by A. Then we can write that rho is equal to R A by L. So what is the unit of rho that we can find from this formula? That is equal to ohm, and A is the cross sectional area, that is calculated in meter square divided by length in meter. So meter will cancel out, and so the unit of resistivity is ohm meter, or simply ohm meter. This is the symbol of ohm, that is omega m. Resistivity of most of the materials is known, and will display here some of the materials and their resistivity. Let us tabulate material name, and here is the resistivity in ohm meter. Silver, for silver it is 1.6 into 10 to the power minus 8, and copper, for copper it is 1.68 into 10 to the power minus 8. Aluminium it is 2.665 into 10 to the power minus 8. For gold it is 2.44 into 10 to the power minus 8. Then for silicon it is 2.3 into 10 to the power 3. For Teflon it ranges from 10 to the power 23 to 10 to the power 25. For wood it ranges from 10 to the power 14 to 10 to the power 16. From this material resistivity we can see that silver, copper, aluminum, gold, these are good conductors. You can see the resistivity is very little, that is 1.6 into 10 to the power minus 8. For copper it is 1.68 into 10 to the power minus 8. For aluminum 2.65 10 to the power minus 8. Gold 2.44 10 to the power minus 8. And for wood and Teflon the resistivity is very high. Due to the very high resistivity, these are called insulators, and these are called conductors. Good conductors. These are good conductors. These are insulators. And silicon and some other material like germanium, they are called semiconductors, because you can see that its resistivity lies between these two values. Here you can see that these are good conductors, but mainly aluminum is used in electrical industry, aluminum and copper, because aluminum is very cheap, it is mostly used, and then after copper is also used. But silver has got some limited use because it is very costly, and gold is almost not used, and these two materials are used for insulation of the electrical conductor. Now from again looking at that equation, we can calculate the value of the resistance of any conductor by simply measuring its length and its cross-sectional area and putting the value of this resistivity. We can calculate the resistance of the material. For example, this is a conductor is made of aluminum. Its cross-sectional area is known, the cross-sectional area, and its length, this is the length is known. Then its resistivity we can calculate from this, its resistance we can calculate from this formula. Also, if the conductor is bigger one, then its area of cross section we know, and this length also we know. Suppose this is L2 here, this is L1, this is A1, and this is A2. Okay, in this case resistance R1 will be equal to rho L1 by A1. In this case R2 will be equal to rho L2 by A2. In both these cases you can find that these are the resistivities that is same because they are made of aluminum. This is also aluminum, and you can simply put the length and the area of cross section and the resistivity in the formula, and we can get the value of resistance. Thank you.